Back. This is problem 5, section 4.1. The area A of the region S that lies under the graph of the continuous function f is the limit of sums Rn's. Now, if you have gone through the problems 1, 2, 3, 4, you will now understand what this is. Use this definition to determine which of the following expressions represents, which of these expressions represents the graph, area under the graph, fx equals x cubed from x equals 0 to 1. Okay. So, fx is x cubed, x equals 0 to 1. That is, the length of the entire interval is 1. As there are n rectangles, the width of each rectangle would be 1 over n, because total length over number of rectangles, 1 over n. My function is fx equals x cubed. All right. So x cubed. So 1 over n means either this option or this option. Of these two options, my function is x cubed. So we have the answer, and that is C. Okay. Now let me submit and check. That's correct. Which brings me to problem B. Problem B, question says evaluate this limit. Okay. We have to use the following formula: 1 cubed plus 2 cubed plus 3 cubed all the way to n cubed is summation I cubed. So this is n times n plus 1 the whole over 2 entire square. This is a formula, by the way. 1 cube plus 2 cubed plus 3 cubed all the way to n cubed is this formula. Now, if you don't understand what this means, pretend what is n. Let's start with an example. Suppose n is 5. Okay. So what is the left hand side? 1 power 3 plus 2 power 3 plus 3 power 3 plus 4 power 3 plus 5 power 3. That's what this means. Start from 1 power 3 until n power 3. n is 5. What is this? 1 plus 2 cubed is 8 plus 3 cubed is 27 plus 4 cubed is 64 plus 5 cubed is 125. What is this? 1 plus 8, 9 plus 27 is 36 plus 64 is 100 plus 125 is 225. On the other hand, what is this formula? It says n times n plus 1 over 2 power 2. What is n? 5. What is 5 plus 1? 6 over 2. I want to take this quantity and raise it to the second power. That's what the right hand side says. Simplify. 2 goes in 6 3 times. So it is 5 times 3 power 2. That is 15 power 2. That is 225. See, they agree. That's what this formula tells me. Okay. So we need to use this particular formula to evaluate this limit. Okay. So let's evaluate this limit. Simplify, right? Look, n has power 3 here from this one. N is denominator. And there is a power 1 here. In all, power 4. This summation I goes from 1 through n. So n is constant for I. So I'll bring that n out. So n power of 4 is out. Look, n is not a constant here. N is going to infinity. So I cannot bring it out of the limit, but I can bring it out of the summation. For the summation, I is the running variable. Okay. So what's remaining? 1 upstairs and I to the power 3. So it's only I to the power 3. Aha. What does this mean? This actually means 1 cubed plus 2 cubed plus 3 cubed all the way until n cubed. That's what this means. This means all of this. But we just saw this is same as this formula. So I will replace this summation I going from 1 to n of I to the power 3. I'll replace that quantity by the formula. Okay. And I'm going to take limit. Aha. This is power 2. So look, 2 goes here, n squared. 2 is applied there, n plus 1 quantity squared. 2 to the power 2 is a 4. So let me combine them all together now. N squared, n plus 1 quantity squared over 4 n to the power 4. Okay. So n to the power 2 cancels 2 of the powers. I'm left with n squared. Continuing. This 4 is a constant, so I bring it out because it's in the denominator, it is 1/4 outside. So limit n approaching infinity, n squared and n plus 1 quantity squared. I'll write it in one parenthesis, all power 2. Division distributes, so that is 1 plus 1 over n parenthesis square. Taking limit, this goes to 0. 1 plus 0 squared. Final answer 1/4. So the limit I have is 1/4. All right. Until next problem.